Hi everybody, welcome to the second lesson of this course on internet technologies. I'm Vardan and today we will be studying about networks and how data flows on these networks. So a computer network is a communication system for connecting computers. Now, why do we have computer networks? Their need arises out of several requirements. A few of them are listed here, that is, they are connectivity, communication, community, and resource sharing. All in all, networks allow us to bring people together and help them collaborate. So we broadly have networks of two types. One is a local area network, the other is a wide area network. So local area network covers a small geographic area. It is owned by a single organization or a single person. It is usually faster, and the technologies it employs are Ethernet or Wi-Fi, and it has a lower setup cost. So think of LAN as a network in your house connecting your laptop, phone, and printer. Coming on to wide area network covers a large geographic area and it relies on shared infrastructure like internet service providers, and it is typically slower than the LAN, depending on the connection type, but usually it is slower than the LAN, and it uses technologies like routers, satellite links, leased lines, and it has a higher cost of setup. For instance, the internet is a wide area network, or a multinational company's network connecting offices in different countries. That also forms a wide area network. So, data travels across a network through a series of decision points. These are systems that determine how and when that data moves. So, in this diagram, you can see that we have a sender and a receiver. But sender and receiver may not always be connected directly, but they could be connected via a network of intermediate nodes. And circuit switching and packet switching are two different methods that networks use to manage how data travels between the devices. Starting with circuit switching. In circuit switching, a dedicated communication path is required between two stations, and the path follows a fixed sequence of intermediate links, and a link is dedicated entirely to the connection. For instance, in this diagram, we have a sender and a receiver, and when a connection is established between these two, all of the data has to follow the same path. And in circuit switching, the data is bit by bit continuous. That is, the data is in a continuous bit stream. This makes 100% utilization of the link when the transmission is taking place. And circuit switching guarantees bandwidth, but it is inefficient. So it is reliable, but it is inefficient because internet traffic is inherently bursty in nature. So there is a burst of activity, and so we're wasting channel capacity when there is no traffic, but the link is still occupied. Now, packet switching is a modern form of long distance data communication, which has now also been adapted for smaller LANs. In this case, the resources are not dedicated and a link can be shared. In this case, the data is transmitted in small packets, unlike circuit switching, which transmitted data in bit by bit continuous form. Here we have packets. So a big chunk, a big message is broken into packets, and each packet has a header containing routing information. And every packet may take a different path to the destination. So they may arrive out of order, or some may even be lost. Now, packet switching is based on store and forward approach. So each node must receive a whole packet, then decide to route it forward. And meanwhile, the node stores it in a buffer and runs checksum on it. And because the link is shared, again, we are making better utilization of the network resources. And this technique is suitable for computer generated traffic uh, and internet generated traffic, which I talked about, that is inherently bursty in nature. Now we have two ways to transmit the packets. One is a virtual circuit and the other is a datagram. So in virtual circuit approach, before the data is sent, a virtual path is established through the network, like a temporary private lane. All the packets follow the same path which is made during the connection establishment. For example, we have a sender and a receiver, and they have established a connection between them. But this is not a dedicated connection. And the main difference that lies between both the virtual circuit approach and circuit switching is that in virtual circuit switching, there is a sharing of link and the data travels in packets, not a bit stream. And the packets only need to carry a virtual circuit number in this case, not the entire destination address. And routers don't have to take a routing decision. They just look at the virtual circuit number and forward the packet accordingly. Now, datagram approach is a connectionless approach. So no route is established before communication, and packets are transmitted independently and thus may take different paths and may arrive out of order. Some packets may be lost if a node crashes. In this case, the routing is dynamic. That is, every intermediate node has to take routing decisions dynamically for every packet. This also helps handle congestion and link failures. And this approach turns out to be faster than the virtual circuit approach if the amount of data is small. For instance, we have the sender and the receiver again, but this time we have datagrams which can travel independently. They can take any path in this network. So all network communication is susceptible to delays. So we mainly have three types of delays in communication. They are propagation delay, transmission delay, and processing delay. Propagation delay is the time taken for a signal to travel through the transmission medium, like a fiber optic cable, and it depends on distance between the sender and the receiver and the speed of signal in the medium. So for instance, in fiber optic cable, the speed of the signal is two-thirds the speed of light. That is 200,000 kilometers per second. The next is transmission delay. The transmission delay is time taken by transmitter to send out a packet onto the medium, and it depends on the size of the packet and the transmission rate of the link. Processing delay is the time taken by the internetworking devices to process the packet header and check for errors and determine the routes. And it depends upon the router's processing capability, the complexity of routing protocols, and how long is the queue. So this value is usually very small, microseconds to a few milliseconds, but it can increase under heavy load. And the total delay of the network is the sum of all individual delays a data packet experiences as it travels from the source to the destination. And with that, we've come to the end of this lecture. And in the next lecture, we'll learn about the layered network architecture and the OSI model. So thank you for learning with me and see you next time.